Good morning, students. In the previous session or previous video, we had a discussion over the 16th group elements, the introduction part of group 16th element. The 16th group elements are oxygen, sulfur, selenium, tellurium, and polonium. So these are the five elements present in the group 16. The properties in the first part of the group 16th elements, we have discussed the atomic property and also occurrence of these elements. Oxygen is the most abundant element in the atmosphere compared to the other all elements. Sulfur present very a small quantity around 0.03% to 0.1%. And others are shows little bit radioactive property. Polonium is radioactive elements. Okay, next move on to the atomic properties of these elements. Okay, the common electronic configuration in first atomic property, it is electronic configuration. The common electronic configuration of group 16th element is ns2np4. So it is present fourth group of the p block elements, therefore it is a p4. There are 4 electrons enter to the p orbital. According to the electronic configuration of these elements, we will discuss the important atomic property in this video. Okay, the first one, oxygen. What is the atomic number of oxygen? Sulfur, selenium, tellurium, next polonium. Okay, so these elements, in these cases, the electronic configuration is completely dependent upon the atomic number. The atomic number of these elements we discussed in the previous session also. Okay, once again I would like to write the atomic number of these elements. Atomic number. Okay, it starts with oxygen. Oxygen starts, it is 8 plus 8, 16. Next 34. Next is 8 plus 8 plus 18 plus 18. Okay, it is 52 plus 32, it is 84. So these are the atomic number of these elements: 8 plus 8, 18, 18 and 32. Okay, so these things you are already well known about the well known thing. Next, electronic configuration of these elements. Electronic configuration is heads with or with the noble gas. The oxygen electronic configuration is helium 4. Next is Ns, correct? So it is 1s2 is completed. Next is 2s2, 2p4 is the electronic configuration of oxygen. So 1s2, 2s2 4 electron and p4 4 electron, total 8 electron. Next, in case of sulfur, helium, neon is 3s2, 3p4. Next, helium, neon, argon, 4s2. Okay, it is now d orbital is entered, therefore we should write first d orbital is 3d series is entered along the period 3d, then 4s2, 4p4. Next, helium, neon, argon, krypton, 4d10, 5s2, 5p4. Now here 18 plus 18, now 18 because of the presence of the d orbital. Now f orbital is entered, because of that it goes to 32. So helium, neon, argon, krypton, xenon, 4f14, 5d10 because of the presence of f and d orbital. Next 6s2, 6p4. So these are the electronic configuration. So electronic configuration is also important for your exam point of view, for the as well as for the study of your complete atomic properties of these elements. Okay, let us discuss about the few atomic properties of these elements. The atomic radii. How atomic radii varies. When we observe the electronic configuration or atomic number, it clears that number of electron increases because of the more number of electron. The orbital is increases, size is increases, volume is increases. Because of that, down the group, atomic radii increases. Down the group, atomic radii increases. Okay, next, what about the ionization enthalpy? Okay, ionization enthalpy. Ionization enthalpy or ionization energy. What about the ionization enthalpy of these elements? Ionization enthalpy is completely depend upon the electronic configuration, or the depends upon the arrangement of the electron, how the electrons are arranged, and what is the stability of that element. Here, the p orbital, the outermost orbital, p orbital, contains 4 electrons. We know that the capacity of the p is 6, correct? Capacity of the p is 6. It is fully stable. The half of the p become p3 is also stable according to the half-filled electronic configuration. These two states is fully stable. When we observe the electron configuration of these elements, or the common electron, according to the common electron configuration of these elements, P4 is there. So P4 is less stable. It tries to become stable by gaining the 2 electron or by losing the 1 electron. That means to getting stability, always it has tendency to lose 1 electron. When it loses 1 electron, it becomes P3, half-filled electronic configuration is stable. Also, it tries to take 2 electron. When it takes 2 electron, it becomes P6. Again, it becomes stable. Tries to loss of 1 electron or gain to 2 electron. Because of that, ionization enthalpy of the group 16th elements is low compared to the 15th group and the 17th group. Okay, now what is the order of ionization enthalpy? Therefore the things is arises, what is first ionization enthalpy, what is second ionization enthalpy, what is the order of that things. Okay, first thing is, when we move down the group, atomic radii increases. Because of that, ionization enthalpy decreases. Ionization enthalpy decreases. Here atomic radii increases, ionization enthalpy decreases down the group. What is the ionization enthalpy, or ionization enthalpy, how ionization enthalpy varies in along the period? When we consider the period of p orbital, it is 13, 14, next 15th group, 60th group, the next one 17th group, and the 18th. Correct. So these are the different groups present in the p block. Here 13th and 14th and 15th, now it become p3. In case of p block, or sorry, p 15th group, it has common electronic configuration p3. P3 is half-filled, therefore it is stable, half-filled stability. and in case of a 16th group it is P4, therefore it tries to lose one electron, or removal of one electron is very easy. In another word, removal of one electron from 16th group is easy. When it loses one electron, that is the first ionization enthalpy. Removal of first electron, it is the first ionization enthalpy. First ionization enthalpy of 16th group is lower than that of 15th group. Okay, that is the conclusion. Okay, when we studied the ionization enthalpy along the period, this is the case. Ionization enthalpy, first ionization enthalpy of 15th group is lesser than that of the higher than that of the 16th group, or 16th group first ionization enthalpy of 16th group element is lower than that of the 15th group. Okay, now what about the second ionization enthalpy? When we remove another electron, in case of removal of another electron, already one electron removed from 15th and the 16th group, therefore a 15th group now become, it is P2, here it become P3. P3 is stable according to the half field, therefore now second ionization enthalpy of the 16th group elements become more. Second ionization enthalpy of 16th group is more than that of the 15th group, reverse. Okay, delta H12 of 60th group is more than that of the 50th group now. Okay, so this is about the ionization enthalpy along the period. Next, electronic configuration. Electronegativity. Okay, electronegativity. What about electronegativity of these elements? Oxygen, we already know oxygen is shows high electronegativity. Yes, oxygen shows high electronegativity compared to the other element present in the group 16th element. It is because of the smaller size and more has tendency to attract electrons strongly compared to the other elements. Completely depend upon the atomic size it is. Okay, so electronegativity of oxygen is more compared to other element. It clears that electronegativity move down the group decreases. Okay, both ionization enthalpy and electronegativity decreases. Here there is another atomic property observed, that one is electron gain enthalpy. Okay, another one, electron gain enthalpy. Electron gain enthalpy, EGE, electron gain energy or electron gain enthalpy. What is the meaning of electron gain enthalpy? Energy released after addition of electron from infinite space. So here electron gain enthalpy. What about the electron gain enthalpy of the group 16th elements? When we add the electron to the these elements, oxygen, sulfur, like that, how electron addition. Okay, I am here adding one electron. What is the amount of how much amount of energy released? The amount of energy released is completely depend upon the stability. When we add one electron, it become more stable compared to P4. P5 is stable, correct? Therefore energy released. When we add two electron, more amount of energy released. Electron gain enthalpy. What is the meaning of electron gain enthalpy? Energy released after addition of electron. When electron is added, the energy released, amount of energy released become more and more in these cases because of the getting the stability. It gets stable, or it becomes stable by loss of the energy. Therefore, these elements shows electron gain enthalpy. Remember that group 16th element shows electron gain enthalpy. Electron gain enthalpy of oxygen is more here. Okay, oxygen is more, but electron gain enthalpy of group 16th element is lower than that of electron gain enthalpy of 16th group is lower than that of 17th group, or is higher than that of the 15th group, very higher than that of the 15th group. Okay, 15th group not tries to shows electron gain enthalpy because it is shows half field stability. therefore never tries to take electron, or addition of electron become, in another word, addition of electron become difficult. Now next, what is the value of electron gain enthalpy? Any element which shows more electron gain enthalpy means it has, or it shows more negative value. What is the reason of more negative value? Energy released. Energy released means loss of energy, therefore represented using negative sign. Okay, it is important again. Okay, more negative means more electron gain enthalpy. Oxygen shows more negative value compared to the other element present in the group 16. Okay, so these are the very important atomic properties. Let us move on to the physical properties of these elements. Physical properties. Under the physical property, states and other things are metallic property, solubility and all that. When you observe the states of these elements, oxygen exists in the gaseous state, sulfur exists in solids and as well as gaseous state. So S2 is gas, is a gaseous state of sulfur. S6 and S8. So these are the solid states. Okay, solid state, and others are solids. Except oxygen, other elements shows or exist in solid state. Okay, next, what is the physical property? What is the metallic property of these elements? Oxygen is non-metal, non-metal, non-metal. These two are metalloids. Next is metal. Metallic property down the group increases. Metallic property down the group increases. Next, solubility. Almost all these elements are soluble in water. Okay, oxygen readily soluble in water. So the solubility of water is oxygen in water is 40%. You know that in ordinary case or sea water contains 40% of oxygen. It is very helpful to marine fishes and all that. Okay, next, chemical property. Okay, important thing is chemical property of these elements. Under the physical property, melting point and boiling point also. So that indicates oxygen shows lesser boiling and melting point. Down the group, boiling point as well as melting point. Down the group, boiling point, melting point increases. Okay, down the group, boiling point and melting point increases. Next, chemical property. Chemical properties. Under the chemical properties, reactivity as well as reactivity and oxidation state. Oxidation state is also play an important role in your P block elements. In case of oxidation state, here oxidation state of group 16th elements, the common oxidation state is minus 2. Common oxidation state is minus 2. Oxygen shows minus 2, sulfur shows minus 2, selenium shows minus 2, tellurium shows minus 2. So minus 2 is the common oxidation state, and also it shows other oxidation state. Oxygen shows minus 2 except OF6, here plus 2. Oxidation state of oxygen is plus 2. Sorry, OF2. In case of more electronegative atom, which one is the more electronegative atom? Chlorine is the more electronegative value in the periodic table. Therefore, chlorine is the more electronegative. That combined to oxygen shows positive. In other cases, oxygen shows minus 2. In peroxide it shows -1. Peroxides, oxygen shows -1 oxidation state. Next, sulfur shows -2 as well as the positive oxidation state. These elements shows positive oxidation state +6 and +4. These two are also the oxidation states of the group 16th element except oxygen. Okay, except oxygen, other shows +6 and +4 oxidation state. What is the order of +6 oxidation state in the group 16th element, and what is the order of +4 oxidation state in the group 16th elements? +6 oxidation state. What is the meaning of +6 oxidation state? This one, NS2 NP4. It is the common electronic configuration, correct? When it loses all 6 electron, it becomes a +6. When it loses only 4 electron, it becomes +4. Here, when we move down the group, clearly observe that when we move down the group, +6 oxidation state, or possibility of +6 oxidation state is decreases. +6 oxidation state decreases, +4 oxidation state is increases, or favorable factor or stability. +6 oxidation state move down the group is decreases, +4 oxidation state is increases. It is depends upon the inert pair effect. What is inert pair effect? The same thing we were discussed in the last session also. Inert pair effect, or in case of the study of the oxidation state of the group 15th elements, inert pair effect means the inner electron is electron present in s orbital. Inner electron, it's a pair of electron, two electrons are paired. It shows stability, it has some stability, and it is very near to the nucleus. Because of that, strongly attracted from the nucleus. Because of strongly attraction and the stability of these two electrons, never tries to lose or never gives these two electrons when size increases. When we move down the group, size increases, correct? Yes, size increases, volume increases, P goes away from the nucleus or core. P goes away, S present near to the nucleus compared to P and S, NS and NP. So because of that, the two electron present goes inner side. These two electron get stability, inertness is observed, inert pair effect is observed. Due to this +4 oxidation state, when we move down the group, these are tries to show +4 oxidation state. +6 oxidation state is decreases. +6 is observed mainly in case of a sulfur. Because of that, +6 observed in case of sulfur, and sulfur forms SF6, SF4. So these are the different halides of sulfur. When fluorine is in contact with the sulfur, it shows SF6 compounds and SF4 compounds. Okay, so it is because of the inert pair effect. We can't observe any polonium F6. It is not observed because of inert pair effect. Okay, these concepts are very important for your competitive exams. Okay, when inert pair effect play in role, when stability comes plays an important role during the oxidation state, how oxidation state varies depend upon, or we know that we completely understand the concept of the oxidation state of all element. The writing the compound is easy, writing the reaction become easy and all that. Okay, so during the writing the correct compounds and balancing the equations on reactions, we should know the stable compounds and all that. The stable compounds is completely depend upon the stable oxidation state of that element. We should know the stable oxidation state of the elements. next it become easy. Writing the compounds, reaction, all things become easy. Okay, suppose we don't know about the oxidation state, then